Okay, so we'll look at quotient rule. So quotient rule is obviously ones that are divided by each other. Okay, now again, it's functions that you couldn't simplify down. So like in higher, you would split them up. You could actually use the quotient rule from that. So a lot of the time in advanced higher, people just forget that you can split things up and just use the quotient rule. It's absolutely fine. But it's for functions that are obviously not related to each other, i.e. like that example 7, x and sine x. There's nothing we can do with them. In terms of your formula for it, none of this is on your formula sheet, okay? That's why we kind of think of ways to remember it. Again, I'll post the proof. So it's very similar to product rule. So you're differentiating the first function, times it by the second function, differentiating the second function, times it by the first function, but actually it's over the second function all squared. This is the best way to think about it. F dash g minus g dash f, so it's a minus instead of a plus, but we divide by g squared. Again, I'll post the proof in the comments if any of you are interested in it. So I'm going to do the similar sort of thing. I'm going to do my function at the side. We need to look for things like chain rule in every single example, okay? These two examples do not have chain rule, but you need to be thinking about it in everything. And again, I would simplify down if the question specified. When we look at past papers, we'll see that. So we have got f and g. You can pop them outside if you want. So f is just x. Obviously, x differentiates to 1. And then g is sine x. Nice and easy. Sine x differentiates to cos x. So we're looking for divided by dx or f dash of x. Doesn't really matter. So f dash g minus g dash df. Now, I've got a massive formula sheet for you. So when we're in, I should be back on Friday, I'm going to give you out a SQA formula sheet so you can get used to it. It'll be needed in the next part of differentiation. And I've got a booklet that's basically all the formulas you need to know. There's quite a fair bit to remember for advanced higher that's not given to you. And this is obviously one of them. So f dash is 1. I just like to put that in anyway, times g minus g dashed, which is cos x, times f over g squared. So g squared is obviously sine, so we're going to have sine x all squared. Again, I'll just write it like this and then I'll tidy it up on the next line. So we've got sine x minus x cos x all over sine squared x. Okay, can't do anything with it. It's not asking me to simplify, but again, sometimes there might be situations that you could take out a common factor and simplify them. Now, we do tap in slightly with, a bit higher. Find the x coordinates of the stationary points on the curve, okay? So it's just asking you to find the x coordinates, not doing anything with them. Whole point is that you know that that's differentiation. So we've got two functions, obviously. So divide by dx, and they're dividing. So f dash g minus g dash f over g squared. Same as before. Just up over there, so we've got x cubed and x minus 5. In applications as well of calculus, we do look at stationary points again, so we'll kind of go back over this. But we'll touch on it slightly in some of the, if it's from higher, it's not anything new, so it's going to crop up every so often. Right, f dash g. So f dashed is 3x squared times g, which was x minus 5, minus g dashed, which is 1, times f, which is x cubed, all over g squared, x minus 5, all squared. Okay, now, this one's kind of obvious that you could tidy this up, right? So that's going to give you 3x cubed minus 5x squared, no, not 5, 15, minus x cubed. Especially because this has got like a part, it's asking you to do something with this. So think like back to functions in higher. You multiply out and you've got something to do with it. Think about like f of g of x sort of questions. So 2x cubed minus 15x squared over x minus 5 all squared. Okay, so that is our derivative. Question's asking you for the coordinates of the stationary points. Now we know stationary points. We know that dy by dx is 0. So what we're going to do, yeah, there's space underneath. We're going to set this equal to 0. So for stationary points, 2x cubed minus 15x squared over that is 0. Now, we need to work with this, obviously. If you think about it, you bring up that function on the bottom. It's just going to times by 0, so it disappears. So whenever you've got a fraction, the denominator will disappear if it equals 0. We want to work with this. Again, you can see, oh, we've got a common factor. So let's take that out. Like you would in higher. Bring them down. And that'll obviously going to take that over. 2x is 15. 7.5, 15 over 2, whatever you want to leave it as. And that is us. Okay, just asked you for the x coordinates, nothing about them. Just that wee bit extra on the end. So I've left you some questions to do again, just to practice. Quotient rule. Some of them are a wee bit tricky, like prove that duab dx is this. Again, that is when you're trying to take out common factors, try and work with your fraction to try and get the answer. Any questions, please type on the chat. Or, you know, I can obviously phone in for Teams. I'm just feeling absolutely horrendous and I don't want to come to school and infect you. But I will be here if you're stuck, obviously, and you can come and see me on Thursday, Wednesday. Come and see me on Thursday, and then obviously I'll see you on Friday.